Hello again, as you know, I am Eli, the computer guy, and today's class is Industrial Networking Introduction. Now, a very important concept that we have been talking about in the IT world for about the last decade is something called convergence. Convergence is where we take all of these old electronic systems that used to be siloed within their own infrastructures, and we start using TCP/IP and Ethernet to allow them to communicate. So when we're talking about the voice realm, this is going from analog and digital phones over to voice over IP. If we're talking about the video realm, this is going from the old, cable boxes or over-the-air television, and now going to IPTV, so using things like YouTube or Hulu and such. Well, convergence is going on in more places than just the consumer realm. So again, when we normally think about convergence, we think about things like voice over IP. We think about things like YouTube. We think of things like IP, digital surveillance cameras. Those are the big things when we think about convergence. But convergence is also happening in the industrial world, and this is something that you should be thinking about. So there are many, many, many industrial systems out there doing all kinds of wacky ass things. So think about it. When you go into a warehouse, when you go into a facility, there are a lot of electronic sensors and devices that automatically go about their jobs, and previously they were using some kind of analog or non-IP system. Now the industrial world is using convergence. It is now taking those devices and those sensors, and now they are using IP, they're using Ethernet, they're using all of the networking standards that we are accustomed to. Now, why we're doing an introduction to industrial networking class is because the industrial world is different than the consumer world. In the consumer world, if you have to reboot your router once a week, hey man, no big deal, right? Oh no, let me go downstairs and unplug the router and plug it back in. It's not a huge issue. When you go into the commercial world, you don't want to be rebooting your router or your switch every week. But honestly, if you have to do it every month or two, it's no biggie, right? You get some really good Cisco equipment, you get some good equipment, and hey, if you have to reboot that thing every once in a while, it's not a huge issue. It's not something you want to do every week, but it's not a real major concern. Well, the thing is, in the industrial world, they put this networking equipment into places you don't necessarily want to be going once a week or once a month or frankly even once a year, right? Because in the residential world, your networking equipment is probably sitting down, sitting by your underwear somewhere. It's in the living room, it's in the bedroom, it's whatever. In the commercial world, your servers and your networking equipment is all sitting into either some kind of server room or IDF. Worst case scenario, maybe you have a couple of spiders that you have to worry about. Oh no, there's cobwebs and dust and dirt in here. Icky, right? But in the industrial world, the networking equipment is actually running in dangerous locations or running dangerous items. So when we're talking about industrial equipment, we're talking about things like robotic warehouse systems. So I went and I did a tour of Phoenix Contact a couple of weeks ago, and they were showing me how their industrial networking equipment actually sits on the back of these massive robots that zip back and forth down their warehouse aisle. So these robot things they have like this mast that probably goes up about 4 stories, and they've got this whole bottom base thing, and the networking equipment actually runs this thing back and forth at high speeds, lowering and raising some kind of like lift mechanism that has like a robotic arm to grab stuff and pull it down. So the thing is, when these things are whipping back and forth at like 50 miles an hour, you don't necessarily want to have to get into the middle of that mess, or you don't want to have to shut down the production line, right? Because if you have to reboot your server, if you have to reboot networking equipment in an office, oh no, everything's down for about 5 minutes. People are not going to be happy with you. No. But it's not really a huge issue in the scheme of things. In industrial environments, especially in factory environments, all of these different processes lead into other processes. So if you have systems that are creating one kind of widget, and then another system is supposed to do something with that widget before it passes it on to something else, if this middle system breaks down, that's going to cause backups in the line in all of these places. So when you're dealing with industrial equipment, it has to be exceptionally reliable. It has to be so reliable that you don't have to reboot it very often. You don't have to worry about it. You can just set it up and let it run. One of the interesting things, I was talking to these Phoenix Contact folks, and they were talking about how some of the networking equipment actually sits at the top of things like smokestacks. You know those smokestacks that, I don't know, are like 300, 400 feet up into the air? They'll actually sit up there, and they help the equipment do all the monitoring for smoke particulates and that kind of stuff. And you don't want to have to hike up 400 feet into the air, once a week because you have to reboot it. So when we're talking about these industrial systems, this is what we're talking about. So with these industrial networking equipment have to be able to survive and have to be able to be used in these very, very, very robust environments. So not only do they have to be reliable so that you don't have to reboot them very often, but they also have to be exceedingly rugged. And when I say exceedingly rugged, this is beyond what you're going to be seeing in a warehouse or such. Because again, with this networking equipment in the industrial world, we're talking about things that connect to sensors. Well, a lot of these sensors, they may be out in the middle of nowhere. They might be out in the middle of a desert. They might be out in the middle of the Arctic Circle. They may be in any number of places, so that they have to be very robust in a way that most networking equipment wouldn't even have to think about it. Again, with a company that I went to visit, they were showing me some of their equipment, and I can't recall off the top of my head, but it really was. Their networking equipment could go from like 150 degrees above zero to at least like 50 or 70 degrees below zero. That was the tolerance their equipment could deal with. So can you imagine putting your Linksys router outside when it's 20 degrees below zero? I don't think it's going to last very long. But again, when we think about this world of convergence and where all this different type of networking equipment is going to go, we have to be thinking about things like this. And so this is where the industrial networking equipment comes in. The other thing with industrial networking equipment is that it goes into very unique environments. And when I say very unique environments, I mean they go into environments where there may only be one of those environments in the entire world. So if you take your Linksys router, it's going to go into your home. And your home, like it or not, is a lot like a billion other homes on this planet, right? So when you put it in, you've basically got the same requirements as a billion other people. When you take the Cisco gear or the Juniper gear and you put it into an office environment, the same thing. There's hundreds of millions of businesses out there, and they all basically use networking equipment basically the same way. It's not really unique. So you buy one, you can use it anywhere. Well, with this industrial equipment, literally this equipment can be used in environments where there is only one of these environments in the whole entire world. And so they have to be customizable in ways that normal networking equipment doesn't even have to think about. So that's one of the nice things with the industrial equipment, is that it allows for two things. One, it allows for outside input in ways that other networking equipment doesn't. So basically you can connect outside electronic mechanisms to be able to fire off tasks within your networking equipment. So at the Phoenix Contact, the place that I went to, they were showing me these firewall routers that they have. And one of the interesting ideas with it is it actually has a VPN built inside, and the VPN, you can actually set it up to phone home. So imagine you have a robot or you have a device and you want the manufacturer to be able to support that device, but you don't want an always-on connection. You just, if the device breaks, you want them to be able to connect, but otherwise you want to be able to control the switch about whether or not they can connect. Basically what they did with this VPN firewall router is they were able to build an external physical switch, a button actually, and if you press the button outside of the router, that would trigger inside the router to create a VPN tunnel back to the vendor's network. And the thing is that isn't the only thing that could happen. They could actually set that up to do any number of tasks. You could hit that button and all the firewall ports would get blocked. You could hit the button and other things could happen. The idea is that they could truly customize what happened with that equipment from an external source. They could also have that equipment trigger an external source to do different things. So if your wireless router is on, or if your wireless router is sending out a signal, you could have it trigger a light bulb, a 60-watt light bulb outside of it to be on. And then you can look up, and if you see that that light bulb is off, you know that that wireless router, for some reason, an access point, is no longer sending a wireless signal. So then you could call up the IT department and say, hey, you know, at wireless access point number 5, the light bulb is off, so we're no longer receiving a signal. Can you come out and fix it? So this is one of the other things that you have to be thinking about with the industrial equipment, is the inputs and outputs that you can have it respond to and give signals to are far outside what you can normally do with this networking equipment. So these are the things that you need to be thinking about with the industrial networking equipment. They're going to be put in very rugged environments. They're going to need to be reliable, and they can do all of this kind of customizable stuff that is really, really, really pretty cool. So let's go over my little table right now so I can show you some of the stuff. Because again, this stuff doesn't look like normal networking equipment. So again, when these guys sent me this equipment at first and they wanted me to review it, honestly, when I first saw this, I was like, almost like, what the hell am I supposed to do with this? So this is the equipment they sent me, and here's some of the different stuff. This is actually the power supply unit for all of this. These are RS-232 wireless connections. We'll probably talk about in some other class. And this is a managed switch. So again, this is networking equipment that you would find out in the outside world, but it looks differently. We also have down here, I have some other stuff. And this here, these are their wireless access points. So this is where it's fully hooked up. So the power supply is connected in, and these are wireless access points. Again, these are the types of things that they don't look like what you're probably used to in the normal world. Now, one of the big things is the size and configuration. What I like about these things is they connect with something called a DIN rail. So if I go down here and I pull this out, I can pull off this unit. So again, this is their managed switch. Not a lot to say about it. I may do a class later, but this is all it is, and this is what it looks like for industrial equipment. But the cool thing is it connects to this, and this is called a DIN rail. So imagine if you're going to be putting networking equipment into weird places, and you don't necessarily want to have to deal with a server rack or any of that kind of stuff. With this kind of equipment, basically you can just screw one of these DIN rails to the wall. All you have to do is push this in, click down, and then it's secured to the wall. So you secure your power supply, you secure your router and your switch and your firewall, and then away you go. All of your equipment can sit in something like this. Very nice, very neat, very tidy. So that's one of the things when you're dealing with this equipment to think about. And again, this is simply called a DIN rail. Now, when you're looking at equipment like this, one of the things you want to be looking at is it's UL listed, and this is CE. So Underwriters Laboratory, and CE is the European version of Underwriters Laboratory. Now what this does is it says what kind of environments this equipment can work in and what is it tested up to. Again, when you go to Link, you buy a piece of Linksys equipment, it's not really overly tested. Even Cisco equipment to a degree really isn't tested that much. But this equipment is tested to see what environments it can survive in and what environments it is safe to be in. So this particular one, as I recall, there's it's like class 1 zone 2. Why that's important is this can actually be used, as I recall, I'm not a lawyer, don't quote me on this, but this particular piece of networking equipment can actually be used in an environment where explosive gases might be present. So again, this is something that you have to be thinking about in the industrial world. Remember, the industrial world isn't your bedroom, it's not a server room, it's a dirty, nasty place where you have to deal with dirty, nasty things. And so by purchasing things with the proper UL code, you can make sure if this is on some kind of like gas rig out in the ocean, or if it's around some place where there might be flammable gases, then you know that this won't give a spark and possibly cause an explosion in a facility. So again, those are some of the types of things to think about when you're looking at this equipment, the UL and the CE. And again, some contracts, especially the more valuable contracts, you know, when I talk about contracts where you're making a few $1,000s a day profit, well, these are the people that worry about this kind of stuff are the ones that pay you a few $1,000s a day profit. So that's something to be thinking about. Now, one of the quirks with this industrial equipment, just so if you ever have to deal with it, is the power supplies are a lot different. So you'll notice all these little devices, there's no plugs as you would normally think of a plug. So with most electronic equipment, there's a little plug or there's a little hole for a plug coming out of it and you plug it into the wall. With this industrial equipment, especially being in the industrial world, it's being dealt with by engineers, right? They love efficiency and they love reliability. And so having individual power supplies in every single piece of equipment is neither efficient nor reliable. And so since engineers are doing this, they don't do it that way. So all of these pieces of equipment don't have their own power supply. In the industrial world, you actually have a power supply that will power all of these devices. So this power supply gets plugged in, and then from here, the power cables run to your individual devices. Now the thing, again, you don't see any normal power plugs on this particular power supply. The reason is because in the industrial world, they don't do things like plugs. Gosh, plugs are so consumer level to professional engineers. So when professional engineers wire in networking equipment, they literally wire it into the power. So one of the things you're going to have to deal with, and something to keep in mind, is if you're ever going to be dealing with this equipment, you will actually have to get a real electrician in order to connect this to your wall power. So the power, the actual cable from the wall would come out, and then it goes in here and gets connected to here. From there, up here are the different slots, and the power comes out and goes into your individual devices. So if you're going to be dealing with power supplies like this, this will actually, in fact, get cabled directly into the wall. The nice part about that is that you don't have to worry about somebody stupidly unplugging something, right? You don't have to worry about some of the stupid problems, but what it also means is that you're going to have to get a real electrician to set up the equipment. Now, one of the cool things, though, with this power supply, so power efficiency, right? So if each one of these devices had their own power supply, it wouldn't be very efficient. So by having a power supply that they all share, it is more efficient. So you save, whatever, a couple of pennies on electricity every year. But the better part with this is you can actually put multiple power supplies on here in order to power your equipment. So you can actually connect multiple power supplies to create redundant power supplies for all your networking equipment, because everything fails, right? This is best in class, incredibly well built, it's wonderful, it's great, yay, and one of these things is going to break, right? And if one of these things breaks, it means all of your equipment is going to go down. So what's nice is the setup they have is you can actually put a second power supply here or a third power supply here, and now you can have redundant power to all of your devices. Instead of having redundant power in only one unit, you can now have redundant power for all of your equipment. Again, that goes back to that whole scheme of reliability and the things that you have to worry about there. So this is basically, again, this is what we're dealing with when we're talking about this industrial networking equipment. And like I say, it is something that I think you guys should really look into. Again, so with this, you know, this is some of the equipment, and this is some of the other ones. Again, this is another power supply, and then these are actually wireless access points. So you can set them up in bridge mode or anything else there. One of the things, again, you know, when we start talking about how engineers really do things, because these are real engineers, right? You know, like I'm a Microsoft certified systems engineer. Yeah. I won't call myself an engineer around these folks. These folks are real engineers. I'm a Microsoft engineer, really. It is an entirely different world. But what we're going to see here is, you see, even on this DC, it says 18 to 29.5 volts. This is the type of thing that is important in their world, because basically this power supply right here, what it's going to do is it's going to take 120 volts and it's going to take it down to 26 volts, I think is what they told me these things take. So these things take 26 volts. The voltage coming out of your wall is 120 volts, so it steps it down from the wall. It goes from 120 volts down to 26 volts. So you're looking at this and you're going, well, why does it say 18 to 29.5 volts? Well, why it goes higher is because if this power supply is very far away from the equipment that it is powering, you actually lose power the farther you go from the power supply. So as the electricity has to travel through the cable, there is resistance there, and that decreases the voltage on the other side. So in order to get 26 volts on the output where the wires connect to the devices, you may have to tweak this up to like 28 volts here. So it's 28 volts here when it comes out, and then over a certain length, it'll be 26 volts once it actually hits the equipment. So again, these are the types of things that you have to think about when you're using this industrial stuff, and if you ever see this in the real world. So again, like I say, all of this stuff I find to be pretty cool. Pretty cool? I think it's really cool, really. You know, it's like really some pretty cool stuff. Now, for a lot of you guys are going to be like going, yeah, Eli, I mean, that's cute and that's nice, but, you know, what am I going to be doing with industrial equipment? I'm not an engineer. I'm an MCSE. I'm not a real engineer. Well, the thing is, after taking a look at this kind of stuff for a couple of weeks now, what I would like you guys to think about is how this stuff could actually be used in your environments in places where you're probably using equipment that is not optimum for the environment. So, I mean, especially here in Baltimore, one of the biggest problems that we have here in Baltimore is our businesses use really old buildings. And so when businesses use really old buildings, they like to do things such as remodel the CEO's office. They like to remodel the lobby. They like to remodel the cube farm. One of the places they don't want to even spend an ounce of new paint on, though, is a lot of times where the electronic equipment resides. So here in the Baltimore, it's not unusual to have basements that actually have dirt floors. And it's sadly not unusual to have some networking equipment down in that basement. So, you know, if you have your modem, if you have your router, if you have your wireless equipment, basically the boss says, we don't have any other room in the rest of this building. You can put the server in someplace nice, but the networking equipment goes in the dirty, grungy basement. Well, that's not a good place for the networking equipment. Again, things like Cisco work very well in a server room. You put it down where there's dirt and dust and gunk, and, you know, that $5,000 Cisco switch can still die in a year just like a Linksys one can, you know, enough dirt and gunk and stuff. So one of the things you might think about is this type of equipment in those environments. Again, I had clients who ran gas stations. I had clients who ran service stations, who ran horse farms. All of these kinds of places, like everybody else in the world, they need networking equipment. They need this stuff to work. The other stuff that I know I put the stuff in there and it died every year, and every year I'd get into stupid ass arguments about warranty and I'd have to laugh at them, and that's always bad, you know, when the equipment dies after a year and then the client expects you to do warranty work and you have to look at them and say, come on, it's a horse farm. Of course it died after a year. I'm not providing warranty work. So things like this kind of equipment might actually be able to save you a lot of time and energy. You throw in a power supply, you throw in a managed switch, you throw in a router, you put this in that dirty, nasty environment, and it's actually built to be there, right? That's not necessarily a bad thing, I would say. So these are some of the things that you should be thinking about. Again, this industrial equipment is built to be incredibly reliable. You don't have to reboot it. You just plug it in, and away it goes. It deals with all kinds of just nastiness, whether it's 150 degrees outside or 50 degrees below zero. Electromagnetic interference. So again, when I went on the field trip, it was really interesting. I saw some of this networking equipment sitting in a cabinet where it had 450 volts running into that cabinet, and the equipment just kept humming along, right? You know, we all hear about EMI. Oh no, electromagnetic interference, it's going to screw with your networking equipment. And this stuff just was sitting there with 450 volts beside it, like, Yeah, no big deal. Then you've got to think about things like the UL and the CE. What environment can you put the networking equipment in? Again, with this kind of stuff, depending on what you buy, you can put this in areas where there may be explosive gas or where there definitely is explosive gas. Again, when we talk about networking, we talk about TCP/IP, this is no longer the stuff confined to server rooms or confined to homes. It's being used everywhere. So that's really not a joke. That might seem like, yeah, but really that could happen. And then the other cool thing, again, is that it can actually send out signals or receive signals from normal electronic components. Again, with most of the networking equipment that you're going to deal with, it can communicate in TCP/IP and maybe SMS and maybe some other stuff. With this kind of stuff, it actually has relays built into it, so you can have it set up so when it receives a signal from an external button or an external switch or a thermostat or something like that, something will automatically happen. So like with this kind of stuff, you could have it set up to some kind of thermometer, like an IP-based thermometer or whatever. And if this equipment can deal with 150 degrees, when the thermostat goes to 151, it could send a signal. When the equipment receives a signal, it could automatically shut off to save itself. It's that kind of nifty, neat, cool stuff that you could do. If you're in an area where there's a lot of lightning storms, you could come up and you could create one button. When all of the equipment receives a signal on that button, it all shuts down to make sure if a lightning strike happens, all of the equipment doesn't get fried. That's some of the kind of cool stuff that you can do. And it can also fire off external electronic components. A light bulb can go off, a warning buzzer can go off, an alarm can go off, all kinds of cool stuff. So those are some of the things that you should be thinking about, again, once you get into this industrial networking. Really cool stuff. I will warn you, though, when you're looking at this, again, this is industrial equipment. This is not Linksys, this is even Cisco. In order to get the reliability that you get, it does get a lot more expensive. So like each one of these little wireless access points here, each one, not including the power supply that's required in order to power the thing, is about $900 to $1,000. So again, that is something to keep in mind. So if you wanted to set this up as a wireless bridge, your cost is probably going to be about $2,500 for both of these things. Again, depending on the environment. I know a lot of you guys, and I know my fan base, and as soon as I say one of these little access points is $1,000, I know a lot of people are like, that's dumb, Eli, that's dumb. But what I will tell you, again, I'm trying to explain to you guys how the business world works, is the folks who pay $1,000, $1,500 for a single wireless access point are also the ones that will pay you lots of money to install said wireless access point, right? The person who goes out and buys a Linksys wireless access point will probably pay you about $50 to set it up. The person that goes out and buys one of these things for like $1,500 a piece or so are most likely going to be able to pay you $500 to set it up. And honestly, these aren't that much more complicated than a Linksys, and considering they're actually reliable, it's probably easier to set one of these things up and then it's a Linksys. So you can set up a Linksys for $50, or you can set this up for $500 a piece. I'm just saying what kind of equipment I would want to install. So again, just some things to keep in mind. Yeah, that's really all there is to it. Again, this is a little bit different type of networking equipment. Still uses TCP/IP, still uses MAC addresses and ARP and all that kind of stuff. It's just used in a different environment. But as I talk about a lot to you guys, is that kind of environment matters. When we talk about form factor, when we talk about usability, the specific type of environment that equipment is going to be used in is very important. So with this, it's in the industrial setting, so it's built as industrial equipment. So, as you know, I am Eli the Computer Guy. Today's class was Industrial Networking Introduction. As always, I enjoy teaching this class and look forward to seeing you at the next one.